Hello everyone, I am Revati M and my batchmates are Aparna, Aishwarya and Karunya. Our project is guided by Mr. Ruben Thomas, ME, Assistant Professor at Electronic and Communication Department. Our project title is a non-linear transformation based SBox for improving security in AES cryptographic primitives for EMR applications. Our abstract is to investigate a novel AES cryptographic realized on FPGAs which poses a serious threat to real-world application. We demonstrate how a targeted bitstream modification can seriously weaken cryptographic algorithms, which we show with the examples of AES. The attack is performed by modifying the FPGA bitstream that configures the hardware elements during initialization. Recently, it has been shown that cloning of FPGA designs is feasible even if the bitstreams is encrypted. We target the SBoxes of block chippers that can implemented in lookup tables or stored as pre-computed set of values in the memory of the FPGA. We demonstrate that it is possible to detect and apply meaningful changes to SBox cryptographic elements inside an unknown proprietary and undocumented bitstream. Furthermore, we show how an AES chipper level is increased with SBox model. Objective: to increase the throughput range and security of AES crypto system with LUT-based implementation of SBox by multi-level composite field computation-based SBox solution approach. Second, to optimize critical path delay by dividing combinational logic inside the elementary operations for deep pipelining. Third, to overcome the key management issues using biometric driven key extraction process. The existing work. The existing work is a novel method for generation of strong substitution boxes based on coset graphs and symmetric groups. It takes place on the IEEE Digital Journal paper. In the existing work, multi-level SBox units are used for maximizing the confusion matrix during random attacks. Combination circuit is used for SBox implementation which increase security. SBox is modified as one-way mapping function. Linear transformation is converted into non-linear functions. And the drawbacks of existing system is biometric physical identities are directly assessed for authenticity activations in biometric systems. Crypto system key management is a major issue which will be the major cause in hacking. And our proposed system is to design hybrid transformation methods to avoid the possibilities of any key leakages and any vulnerabilities in AES crypto system, to integrate robust biometric systems with unique key generation module for solving key management issues, to improve the overall security with outer layer transformation using multi-level crypto system, implement proposed image metric key driven AES core for EMR applications. And the advantages of our proposed system is data rate is very high, able to process high level chipper in any real time data, outer level security is high, and bio encryption. In this block diagram, we are going to see our overall process. Here, input text is the input passwords or any biometric signals informations we are going to given, and ASCII conversion. In ASCII conversion, the numbers and alphabets are mixed together and which is fed into the key generation. In the key generation, it is also mixed with the biometric informations. From the biometric informations and key generation, it is led into the SBox permutations where the mixed columns, shift key, substitution bytes, the process for securing the password will be done. It is given to the cyclic addition and based on the cyclic additions and key generation output, it is given as the chipper out. From the chipper out, our password is secured, and since the AES is the advanced encryption method, there are some attacks in AES. The attacks are in AES are side channel attacks and differential cryptanalysis. The side channel attacks are the attacks based on studying and measuring the actual implementation of the code, while differential cryptanalysis is the difference in the output based on the input given. In differential cryptanalysis, the hackers used that scanning technique to carry out this attack. It is by calculating the input out on the output difference. If we are giving a number as 1, if the output is 5 and the number as 2, if it is attained, they will analyze it as a multiple of 5. They can easily identify the password and get the password, thread the password by recognizing as it will be a multiple by 5 algorithm. The algorithm we are going to use in the proposed system is in two types: initializing transformation process, replacing S boxes to the identity functions, changing linear S box into a non-linear function to overcome the highly vulnerable cryptanalytical attacks. And next, replacing S boxes to the random function. Bit streams can be altered to always output to unpredicted results regardless of the input value. If we are given the value as 1, for which the output is -1, while for 2, if it is the output will be the -28 or some other anything, it will be a more confusing one for the hackers. Simulated chipper output. As we seen in the block diagram above, the chipper output is the confusing one. If we are not a hacker and we are the user provided by the service providers, we will get the chipper output as 00 for our passwords. If we are the hackers and trying to track the algorithm, we will not get the 0 as the output. And it is the area report, it is the flow summary. It is total register you are using is 40, total pins is 80 by 347, and virtual pins, it is the device or EP3316F 484C6, and the family Cyclone 3, top level entry name S-box. It is the Fmax report. These channel reports Fmax for every clock in the design regardless of the user specified clock periods. Fmax is only computed for paths where the source and destination registers or ports are driven by the same clock. Paths of different clocks including generated clocks are ignored here. For paths between a clock and its inversion, Fmax is computed as if the rising and falling edges are scaled along with Fmax, such that the duty cycle is maintained. This is the linear memory LUT S box. Here it is a linear transformation based S box hardware model, and this is the confused S box, that is non-linear transformation based S box in the hardware view. Logical depth analysis of various S box types. The X box in LUT based and dynamic non-linear based. The area is reduced from 216 to 80, and the Fmax frequency is increased from 228 to 509. This is the biometric digital image. Based on our biometric information, it is converted into bit streams, and the password is selected randomly as any of the 6 or 8 digits based on our requirements. These are our references. Based on this reference, we came to finish our project. successfully with full involvement. We thank our guide and stars who helped us in this project to complete this project a successful one. Thank you. Now we are going to see the stimulation demo for our project, a non-linear transformation based S-box for improving security in AES cryptographic primitives in EMR applications. These are our codes in which we have AES core and biometric out LUT based M code and S-box case 3. Here we have to change all this code into the WordPad format. We search for the code. I will keep the codes in desktop. For example, now I am given an image. In M code we have to upload the image. Here this is a location where I have to read the key. So I am taking this location and copying here. In this folder only we have to read the key, or else change the folder. Now where is the code? We have to go to that location. File name example FHS. I am browsing the code and copying all the codes and pasting here. And I am going to compile the codes. This is the size of the image. If you are giving 256 into 256, 65,536. If we are going to change the size of the picture, if we give 100 into 100, it will give 10,000. And combine all. We have to run this. If we go to the memories, we have the memory as 65,000 as. We will see the memories. If it is in the If we have to change in hexadecimal, we can change it as hexadecimal by going to the properties. From this, here we have the memory address as 65,000 addresses. From that, we will randomly select. It will select randomly a 16-bit address. For that image, it will take randomly a 16-bit address. It can be anything. Words per line, if we change it as 8, it will change into like this. Now we are going to see the comparison. For the normal S box and the proposed system. Compile report. From this we can get the speed analysis. LUT based model is a conventional model and we are using the multiple S boxes. We can view that with the Netflix. From this report, Fmax report, we get that. Next, this is the normal. LUT based model. Here the functions are already predefined. In the proposed, we are using multiple S boxes. For that, we will get the Netflix view. For us, this much inversions, multipliers. This is a proposed models Netflix viewers. This is a proposed model non-linear based transformations in cryptography. Here more number of multiple inverses and S boxes are used. It contains more XOR operations and now I am going to run the original. Now I am going to run and show that. While compiling, we will get alternate more number of cybers. If we enlarge it, we can see it more number of the cyber is changing simultaneously. And for encrypt and decrypt, we have given a key that is fully alphabetics. We can give any codes, anything as a 128 bits key. It can be numbers or characters or something. If we give it as a characters, it is something. It is nothing but ASCII. The AA score is a proposed model S box, and LUT based is a normal S box with LUT based. Here in encodes we can upload images and randomly take the address as password. Now we have to upload the image here only. It will while going to the properties, we will see the type. It is in the form of GIF. We can give any of the models as MB, .mb, anything. You have to change here also as MB. The number of pixels is here is 256 and 256. We can give it as 100. If it give it as 100, it will come as 10,000. Here the memories of the M1, M2, M3 and so on, it goes to 16-bit address. So it will take randomly as the bits are taken randomly and they are concatenated for confusing the hackers. Expanding this. Whether it take a random value or we can assign the value as the concatenation is done mainly by two ways. So whether we can assign here here I didn't give any values and based on the address and changing values, the password is taken as randomly. Now we are taking three example. We can take 3 images and we are uploading it in M codes. When we The address is read by the read from where we are taking the pixels from the num pixels as random. So this is the way the numbers or the password is taken, the secret key is taken randomly. It cannot be judged by the hackers. So it will be a confusing factor. Also the non-linear based LUT, non-linear based AES system is also a confusing one. It has multiple numbers of inverses and S boxes in it, and it also has a speed implementation. So it has higher speed and higher efficiency.
Thank you.